Welcome to Dr. Zahir Math. In this video, I'm going to explain exercise 6.5 from module 3, exponential growth and decay. Only two problems I'm going to explain. One is population model, another one is radioactive decay. These are the two problems I'm going to explain. So listen the question carefully. Before starting this question, you need to remember two formulas for this question. One for population, there is one answer you have to remember, and one for the radioactive decay. It's so easy. But the same problem you will study in the next course, which is after calculus 3, that is the one course called differential equation. In the differential equation, the same problem you will study in detail. Okay. But here we are not going to apply any calculus ideas, no differentiation, no integration, nothing. Just we are going to put the limits value. Keep in your mind. Use the fact the world population was 2560 million in 1950. So let me take the data first. In 1950, how much is the population? Year 19. This I'll take year and I will take the population. Population means what? Number of people. In 1950, the population was, it is 2560 million. Okay, right. Let me read the question next. And 3040 million in 1960. So in 1960, okay, the population is 3040 million. You can say like that. Look here. After 10 years, how much of population increased? See, from 2560 to what? 3040 million. So population increase. How much is the difference? 10 years. After 10 years, you can say like that. Right. Let's go to the next detail. To model the population of the world in the second half of the 20th century, of course 20th century only, assume that the growth rate is proportional to the population size. What is the meaning of that? It means the growth rate is what? The population model is proportional to the population size. This is what? Actually, you didn't study integration. If you use integration, step by step, you will get a differential equation solving and then you will get the solution. So that solution directly we are going to take it in this problem. Right. So the question is, what is the relative growth rate? It means they're asking what is the population. Use the model to estimate the world population in 1993. Right. In 1993, the question is, what is your population? The next question, and to predict the population in the year 2025 also. So in 2025, what is your population? Actually, in the book, the example question is 2025. But in your classwork homework question is, it is 2020 is given. So you do according to that. What is the question asked in the exam? According to that, you try. Look here, from 1950 to 1960, this is actually, we have to call it as initial population, the starting stage. Whenever the data is taken, the first data is called as what? Initial population. So t is equal to 0, your population is 2560. After 10 years, which is t is equal to 10. 1993. From 1950 to 1993, how many years? Totally 43 years, right? So t is equal to 43. From 1950 to 2025, how many years? Exactly, which is t is equal to 75 years. Clear all of you, right? So 1950, add 50, so you'll get 2000. Then add 25, you'll get 2025. So initial things, you take it as t is equal to 0 every time. Then you count according to the number of years. Okay, right. So I told you one formula you have to remember. What is the formula? You have to remember one equation, P equals P naught e power kt. This one you have to remember as a rule. Keep in your mind. This rule you have to remember. Nobody will give you in the exam. So this one you have to remember. P is equal to P naught e power kt. What is P? P is the population. What is P naught? Initial population, right? What is K? Constant. What is T? Time. Okay. So P is what? Population. And what is P naught? Initial population. Okay. And what is K? K is a constant of proportionality. And what is T? T is the time. Right. Now, what are the details given? I'm going to apply one by one. The first detail is what? T is equal to 0, the population P is equal to what? 2560 million. I'm going to use this one. So I'm going to apply this in this equation. Put in equation number 1. So put this detail in equation 1. If I put this one, population is 2560 is equal to P naught. P naught we don't know. E power k into T is equal to 0. So which is equal to 2560 is equal to P naught. E power k times 0 is what? E power 0. So 2560 equals P naught because E power 0 is what? 1. So your P naught is equal to 2560. Right? Clear all of you? Right. So you got the value of P naught. The same, go back to the equation 1 and rewrite again. So now right now your P is equal to P naught e power kt becomes P equals, what is your P naught? Which is 2560 and it is e power kt. So right now this is your equation. Clear everybody? Right. Now let's start applying the second condition. What is the second condition? The second condition is T is equal to 10. The population is what? 3040. So this condition I'm going to apply. So this I'll call it as equation number 2. Put T is equal to 10. The population P is equal to 3040 in equation number 2. So population is what? 3040, right? 3040 is equal to, I'm putting P is equal to this one. So which is equal to 2560 e power k times, okay, what's the value of T? T is equal to 10, right? Now take your calculator, all of you. Take your calculator, right? So now restart your calculator, restart. Make sure it is in degree mode in the screen, okay, right? Then first step is shift mode. Please press shift mode and then you will get, when you press shift mode, you will get number 6, which is fixed mode. When you press 6, the calculator will ask you 0 to 9. So please press 9 and then press equal. Sorry, I'm not well. Press 9 and it is equal, right? Okay. So now it is ready. Your answer will come in 9 decimals. Now please type this equation. I'm saying type. I'm saying type. How to type? So 3040. This equal, you should use alpha equal, which is on the top, alpha pink color, and the equal button is on the cal C button, there is a equal. So please use this alpha equal 2560 e power, use x. Where is x? X is alpha x. Please use alpha x and then use bracket 10 bracket close. Come on. Type everybody. Right. Now use the keys. Keys means the button which I'm telling. So please use shift calc equal. Which equal? The down equal. The last row. Shift calc equal. If you use this one, the screen which you are showing, right? X is equal to L minus R is equal to 0. The screen will show like this. Are you getting the screen like this? And in the X is nothing but your value 0.0171850,256. Are you getting this value? Yes. So this is your K value. This is your K value. So go back to this equation, which is number 2. So the equation 2 becomes, there is no differentiation. Keep in your mind. Equation 2 becomes, what is your equation 2? Equation 2 is P is equal to 2560 e power kt. So P equals 2560 e power, the K value I'm going to put it 0.0171850,256 times T. So this is your relative growth model. Okay. So the word which is asked is what? To estimate what is the relative growth rate. So this is called relative growth rate. This is called what? Relative growth rate. This equation is called relative growth rate. Keep in your mind. Okay. Relative growth rate. Now there are 2 questions in this. What are the 2 questions? Can you see the questions, please? They are asking, in the year 43 years, which is 1993, what is your population? In 2025, what's your population? So for 1993, from t is equal to 0, it's how much? 43 years, because 1950 here and 1993 here. How many years? 1952, 60, 70, 80, 90, 2000, 2000, like this it goes, right? So in this way, you are coming to 93. So 1993 minus 1950 is what? 43. So t is equal to 43. What is your p? They are asking. And t is equal to 75. What is your p? They are asking. This is the two questions, right? So let me solve this two question. So first question I will solve. When t is equal to 43, right? What is your population? T is equal to how much? 43. What is your population? The second question is, when t is equal to 75, what is your population? So in this equation, you put t is equal to 43. Let me call this equation as number 3. In equation 3. Similarly, here put t is equal to 75 in equation 3. That's it. Very simple. So p is equal to 2560 e to the power of 0.0171850.256 bracket open, and t is equal to 43. Put in the calculator, everybody. Just calculate only. 2560 e power 0. Blah, 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 bracket open 43. You will get 5359.996699 million population. But usually we won't say 99 because human being, right? We are all men and women, babies and right? So we won't say 0.98. So 53 more than 0.5, it is 59. You can say 5360 million population over here. In which year? After 43 years. 43 years means what? What is 43 years? In the 1993. Now we are going for what? 2025. So same thing you are going to put here. So what is the equation number 2? Put here p is equal to 2560 e to the power of 0.0171850.256 bracket open 75. Come on, put in the calculator. If you put in the calculator, you will get the value 9289.494876. So this is not above 0.5. So that population will be 9289. Clear, everybody? Right? Suppose this is the million. You can say right that million. So these are the two answers. When you read the problem, it's so big. I know statement problem, English problem, you will find it difficult. But when you read it and collect the data, the problem is so simple. Suppose the question is asked, instead of 2025, the teacher which they solved in the class is 2020. How you will put t is equal to 70. That's it. Very simple. Suppose they ask 2030, you will put t is equal to what? 80. Very simple, right? But this equation or this formula, you have to remember. How you get this solution? From this differential equation. This is the differential equation, right? Because it's having differentials. So usually integration, but you said study in the school this one, but here you did not study. You will study this one in the calculus too. So that's why I'm not teaching this part. I'm just giving you the final answer. So remember this formula when the population model is given. Similarly, the next question is growth decay. So radioactive substance, I'm going to give it. So in this problem also, you are going to remember one formula. That formula also similar to this. What is the formula? I'll tell you. The formula is m of t is equal to m naught e power kt. What is the formula there? P of t is equal to p naught e power kt. It is same like this formula. Instead of p population, here you have the substance mass. That's it. Only thing is this the change. Let's read this question. The half-life of radium-226. It is a radioactive substance, okay? Radium-226 is 1590 years. Keep it in your mind. It is 1590 years. At that time, it is half-life. You have to divide by 2. Keep in your mind. Half-life means you have to divide by 2. Which one? The mass. What is the first question? A sample of radium-226 has a mass of 100 mg. So, this radium-226, the mass is 100 mg. This is half-life period. So you have to divide by this by 2. Keep in your mind. Find a formula for the mass of the sample. It means they are asking the equation for m of t. Right. And the sample remains after t years. Find the mass after 100 years. Okay, it means they're asking what the question what? M is equal to question mark. T is equal to what? 1000. Right? Okay. Right. Let's start the solution. Right. So what I ask you to remember? I ask you to remember m of t is equal to m naught e power kt. Right. What is given? M naught is given. How much? Which is 100 grams. Right. In the year what? 1590. Keep in your mind. Right. That is after t is equal to 1590 years. Right. The mass remaining in the radioactive substance is what happened in the years, right? Mass remaining is half. It is given already in the question. Half of the initial mass. Half of the initial mass. It is given in the question. Half life of radioactive substance. So it means you have to divide 100 by 2, which is equal to 50. Okay, everybody? Clear, all of you? Right. Now this one you keep it in your mind. So this one at 1590, it is going to become what? 50. Now let's go back to the question. M of t is equal to m naught e power kt. First I have to find this m naught. M naught at time what? 1590. So at time it's 1590. Your mass is what? 50, which just now I calculated half. So this equation, this is your equation 1. So this equation 1 becomes m of t is what? 50. Okay. M of t is what? 50 is equal to m naught. I don't know. I have to find e to the power of k times 1590. Right. Just take your calculator, all of you, please. Type this equation. When I say type, you have to type like this. 50 equal. This equal is alpha equal, which is pink color. Keep in your mind alpha equal. And then this m naught. You are going to type it, right? So this m naught is already given, which is given as what? 100. I forgot to substitute this one. Actually, you have to put m naught initial value, which is 100. So e 100 you put it, and then e power this k you use alpha x. This is what? Alpha x, which is given in the calculator, alpha x. And then 1590. Then please press the keys. Okay, what are the keys you need to press? Shift, okay, and then calc, and then equal. If you press this calculator like this, what happens? Again I'm telling, m of t, which is 50, and m naught, it's just 100, initially 100, and then half life is what? 50, and e to the power of k, this one, right? So when you press this in the calculator, your calculator will give you x equals, and L minus R is equal to 0. What is x equals? It is giving in the calculator, it is giving minus 4.35941 multiplied by 10 power minus 4. But usually math teachers, they don't accept 10 power minus 4. You need to convert this in normal decimal. Look here how I convert. X equals minus 4.35941 multiplied by 10 power minus 4. 10 power minus 4 means you have to go to the left side. 1 time, 2 time, 3 time, 4 time you are going. So the fourth time is the point you have to put it. So how many zeros you are going to put? 3 zeros. So x equals negative, because there is a negative is there. Okay, keep in your mind there is a negative. So negative 0 point, how many zeros? 0, 0, 0, 435941. So this is your x value in the calculator, but here x is not there, it is k value. Clear, all of you? Right. So what happened to the equation 1? Equation 1 takes the form m of t is equal to, which is m naught, right? And then what is the value? E power kt. So m of t is equal to m naught is 100, e power minus 0.00043591 times t. So this is the model of the equation. This is the model. Actually, they asked me the question. What is the question they asked? Find a formula for the mass of the sample. So this is the formula for the mass of the sample. This is the formula for what? Mass of the sample, right? This is the A question, right? That is after t years. You can write it after t years, something like that. Okay, right. Now, what is your B question? Your B question is you are going to find the mass after how many years? T is equal to 1000 years. After how many years? T is equal to 1000. So let me call this as equation number 2, right? Is there anything 1, 2 I called? I think 1 only I called, right? 1 I did not call, right? Yes, 1 I called. Okay. Then this is number 2, right? Yes, only 2. So this is number 2. So let me write equation 2. So what is your equation number 2? M of t is equal to 100 e power minus 0.000435941 t. So now I'm going to put what? T is equal to 1000. So this equals 100. Put t is equal to 1000. So what happened to this? Which is equal to 100 e power minus 0.000435941. T is 1000. Put in the calculator, everybody. Okay. In the calculator, you will get 64.665. Calculator is very small. 6658775. So what is the question? Nearest milligram they asked. Can you see that question? I'll read it again, which is nearest milligram. Can you see that? So find the mass T 100 years to the nearest milligram. So it means what? You have to approximate it. That's the meaning. So 64.666, it will give you 65 because more than 0.5. So 65 milligram is your final answer. Clear, everybody? So this finishes 2 questions from exercise, I forgot it, what's the name, 6.5, exponential growth and decay. If you really understood these 2 problems, don't forget to like, subscribe and share it with your friends. Okay. So East or West, Dr. Zahir Math YouTube channel is the best. Okay. Right. See you in the next video. Until then, it's bye from Dr. Zahir. Bye-bye.